Hello and welcome along to Dozzy's Television Workshop. Today we're looking at the extremely humble and much cheap microwave oven. Now there's a huge caveat coming along the bottom of the screen here. Don't try this at home, folks. Where are we? There. Don't try this at home. Now there's a warning on the cover of every microwave oven saying caution, microwave radiation, do not remove cover. I hope you take heed to that notice. Let me take the risks for you here today. If you just want to know what makes it tick, ideal. This one's broken, I'm going to fix it, so you don't have to take that risk. If you do want to get a microwave oven repaired, please find a specialist to do this for you. It's really not worth the hassle, aggravation and danger. There is enough power in most, in fact not if not all, microwave ovens, domestic ones, industrial ones, wherever you go, to floor you or kill you. This is a serious risk. It won't pull your trip if you get a shock. It's not going to blow a fuse if you get a shock. You're just going to know about it. And it is very, very, very serious. People have commented before on my videos about television sets that I should warn people. Yes, there's a higher voltage in a television set, but it's very current limited. It'll frighten you. And to be honest, you probably risk more from personal injury, banging your elbow on something as you jump away from it. But this, the microwave oven, will hurt. It will kill. So don't do it. All right, let me take those risks. Anyway, I shall take absolutely no interest in the warning label at all. I'm going to take the cover off and we're going to have a look and see what's stopped this one from operating. Right, well, let's thrown caution to the wind and got the cover off. Again, don't try this at home. Right, the microwave oven, even its simplest cause, you may have a circuit board and some push button timers. They're all very much the same, except for inverter microwaves. We'll come to those later. Consists of basically a timer circuit, some interlocks for the door being opened, so it shuts the timer off. Some protection, in this case, there's a little thermostat on top of the magnetron here. So if things get a bit overheated, it goes off. That's the magnetron itself. Now, a magnetron, it's a cavity device very similar to a thermionic valve, connections there to that. Now these carry two different voltages simultaneously almost. There's quite a high current, low voltage filament supplied to warm it up, and it warms up very, very quickly. It's directly heated. And the high voltage, is generally supplied by this transformer down here. You'll see people on YouTube using microwave oven transformers to generate thousands of volts, and they do that. So yeah, there we are. Input to the transformer is down here. That feeds a very, very simple half-wave rectifier circuit, which gives us some DC to charge this capacitor up. Now, a note about this capacitor. Under certain fault conditions, especially to do with the magnetron, that capacitor can charge up and hold a deadly charge for hours and possibly days, depending on its condition, after you've unplugged it. So it's not safe, really. You need to make sure that's dead. And with that in mind, I use a high voltage probe to measure its to voltage. This just connects to my ordinary multimeter and gives me a reading in thousands of volts. Okay, now to keep the magnetron cool, it gets very, very hot in use. There's a little fan there just to blow some cooling air across it. That's generally what you can hear running in your microwave. Some mains filtration up here, so any nasty spikes or anything we generate in this circuit don't feed back and pollute our mains, and vice versa. Magnetron itself feeds a very short waveguide here. Now, waveguide is just a hollow tube, and it concentrate the radio frequency energy, but it's used to deliver the radio frequency energy about 2.4 gigahertz, very similar to your Wi-Fi, a lot more power, into the cavity itself where you put your food. There's a bulb as well to light it all up, make it look pretty. That's why you'll see on the side, generally of a cheap microwave oven, top of some posh ones, there's like a almost plastic window, and that's lets the radio frequency through into the chamber. That is all RF tight. The radio frequency can't get out of there. The grill on the window, and by the light bulb generally, they're specially designed. Those holes are there to let the light out, keep the radio in. that's how it works. So there we go. It's a very, very simple circuit. On the output of the transformer, you'll see there are, if you look carefully, there are 3 wires. One carries the filament current, low voltage, high current. The other one supplied via this fuse here, and that supplies the high voltage into the rectifier and the capacitor. It's only a 1 diode rectifier. Sometimes there's 2, sometimes there's 1 back to earth. This one has just got 1 back to earth, so they're rectifying the negative half cycles. So that's it. Charges the capacitor up, and that feeds the high voltage anode voltage to the magnetron. Now, you'll notice that every microwave oven has a power control on the front as well, and this is so simple. You'll notice if, say, you've got an 800 watt microwave on 400 watts, that every now and again it goes dong, and that's actually when it's running. The rest of the time it's actually off. So if you've got an 800 watt microwave, when it's running, it's always producing 800 watts. So what do they do to give you 400 watts? They switch it off for half the time. And I'm not talking about short cycles of milliseconds or microseconds as we'd use to pulse width modulate an LED light for dimming or a motor for speed control. No, this is sort of a second on, a second off, and they just vary that. And on this microwave, you've got the bell, and it's literally done by altering the power control, which pulls a plunger out and operates a micro switch that switches the HT on and off. And they don't switch the high voltage side, they switch the low voltage side. It's safer to do so. We can get micro switches to do that, we can get simple electronics to do that, rather than attempting to switch probably about 2,500 volts on this model. Anyway, what stopped this one was the fuse on the output of the high voltage transformer. It's there for many reasons. Obviously, if the magnetron develops a fault, or if the transformer itself develops a fault, that fuse, or the capacitor even, or the diode, any of that lot, any of that develops a fault, pop, the fuse opens, stops any potential overheating, damage, etc, etc. Now, it also suffers a lot of abuse, that fuse. One, it's a very, very high voltage fuse, generally rated at 5 or 6 kV, and they're not, despite the fact they look like an ordinary 1.25" fuse, they're not. They're a special fuse. When they go open, we need to replace it like for like. So that was actually the fault with this oven. Suffers a lot of stress when it comes on and goes off all the time. That magnetron's being switched on and switched off, switched on and switched off. And every time there's a little bit of inrush current charging that capacitor, and over a period of years, the fuse weakens and fails. In fact, I don't repair a lot of microwave ovens, to be honest. I mean, they're what, 35 quid in the supermarket? They're just not worth even looking at, really. But there it is, and that's a common fault. So this one belongs to my mother-in-law. She'll be delighted when it's done, and it is done. So put a new fuse in there. So we're now going to put the cover back on and give it a quick test. Right, we've buttoned it all back up again. So now time for testing. I shall plug her in. My workshop supply. Oh, there we go. Now, one thing you'll read in every microwave oven manual, and maybe your mum told you when you had your first microwave, I don't know. Don't ever run a microwave without something inside it. Very important. The magnetron, being a radio transmitter, needs to see a load. Otherwise, all that energy going into the cavity is likely to get reflected back into the magnetron, sorry, and do some damage. We don't want to do that, so I've created this wonderful dummy load. Now, this is a mug full of water with a 60 watt bulb in it. So that should give us quite a visual load of whether things are working or not. All right, there we go. Power, full chat, and we'll just give it a quick blast, and we should see the light bulb glow. Again, don't try this at home, folks. So there we go, coming on, magnetron charges. There we go. There's my light bulb lighting up. How about that? Fantastic. We won't leave that running too long. It's obviously not looking like a cup of soup or a pasty, that light bulb in there, so we don't want to do any damage to this now repaired microwave that hopefully will go on for another few years yet. There we go, another item saved from landfill. Thanks for watching, and don't try this at home. Don't do it. Leave it to the professionals. It will floor you and kill you. Don't do it, please. I need all the readers and listeners I can get. There might even be a write-up on the website. In fact, let's do that. We'll do a write-up on the website at andydoz.blogspot.com, and I'll even draw up a little circuit diagram to explain what I've done the video on. There you go. Thanks for watching, and come back soon. Cheers. Goodbye.
We'll be right back.